Then let's go ahead and get started. My name is Danny Rowan Hawk. I'm a math specialist at the Learning Commons, and today I'm going to be going through Test 2 review for Mac 1105C. If I will have the chat open, so feel free to post comments there. The way this review is going to work is we're going to go through quite a few of the Test 2 review questions on here, and we're going to go through them together. So you can unmute to answer, or you can pop answers in the chat since I will be looking at it. You can private message me the questions if you'd prefer as well. I will ask if there's any questions after every exercise we go through. All right, so looking at this first one, this is one of the first things that you guys went through for the beginning of this unit with linear functions. So here it's asking for the equation of the line, and it gives you an ordered pair, and it gives you the slope. So if we're looking at this first one here with the ordered pair -7, 4 and slope of 0, what is the equation of our line?
Are you asking us, or you just saying?
I sure am. I'm asking.
Oh, y equals since the slope is 0, so y equals 4.
Absolutely. Yeah, when we're dealing with something like this where our slope is 0, then that means we're dealing with a y equals b equation. And that means if we're looking at the ordered pair, we're looking at not the x value, but the y value. So it's going to be y equals 4. How about the next one? We have -7, -17, and m equals 9/7. And remember, so we're doing y equals mx plus b, right?
Right.
So our m is 9/7. Now what can we do with that point that we have?
Plug them in.
Yeah, absolutely, right? So if this is our x and this is our y, we're just going to go ahead and plug that in directly. So -17 equals 9/7 times -7 plus b. What happens to those 7s?
They cancel.
Yeah. 7/7 is 1. So we're left with -17 equals -9, because that negative does not go away, plus b. Now we're just moving that -9 over, right?
Right.
So +9 to both sides. And what's b equal?
-8.
Yeah, -8. So if we wanted to write out our full equation, it would be y equals 9/7 x minus 8. And that was our y equals 4. Now you don't have to use y equals mx plus b. You can also use the point slope formula, and we'll use that on one of these down here. What about the third one? If our point is -8, 8, and the slope does not exist, what is the equation of our line?
X equals -8.
Yeah, it's x equals -8. So if the slope doesn't exist, we're dealing with an x equals a equation, and we're just looking at the x value. For this next one, we could set it up exactly as we set up the second one. But what I'd like to do is use the point slope formula to show you an alternative. So previously we solved it by plugging in an x and y to y equals mx plus b. This time, what we'll do is we'll actually bust out the other formula that you guys have been working with, which is that y equals m x minus x1 plus y1. Does that look familiar? In which case our point would be x1, y1. And let's just plug everything in. So you have y equals 2/5 as our m, x minus our x1, which is -5, plus our y1, which is -2. Okay, what's our first step here? Anybody? How about dealing with those parentheses, right? If we have two negatives, negative is a positive, right? So this becomes cleaned up. Y equals 2/5 x plus 5 minus 2. We can just kind of, we know that that becomes just a negative. Okay. So what's our next step?
Distribute.
Yeah, absolutely. We're going to distribute that 2/5 to both terms, right? So y equals 2/5 x plus, and then you have 2/5 times your 5 minus 2. What happens to those 5s?
Cancel.
Yeah. Sometimes we're not as lucky. I'm sure you guys have seen on your homework, we haven't always been as lucky. But when it works out nicely, you're able to cancel them out. And you look at 2 minus 2, which is what? Just 0, right? So this ends up just being y equals 2/5 x. Does anyone need to see the last one? Or do you guys feel pretty comfortable with this?
You can do the last one.
Okay. All right. Since we used point slope for that one, which one would you guys like to see? Point slope or y equals mx plus b, slope intercept, to solve? And our options are this, or this, right? And remember, when you guys are doing this, you got to work with the one that works for you, okay? So if you're a lot more comfortable using point slope, then use it. If you're more comfortable plugging stuff in to y equals mx plus b and solving for b, do that one.
Excuse me.
Yes.
On the last one, I did it the other way, the y equals mx plus b way. And what I got was b was 0, but that'll get the same answer you got, right?
That does give you the same answer. So if you get b, so if you solve that and you get b equals 0, then when you're setting up your formula, you have the 2/5 x plus 0, which is just y equals 2/5 x.
Right.
Yeah, no, you got the same thing. You're good.
Okay.
Yeah, so that's it's great that you brought that up, because that's going to be the difference. It doesn't matter which formula you use. You can use either one. Just know that if you're solving for b, that you've got to then set up the formula afterwards. Let's go ahead and use that one with this one. So we have m equals -4/9, and then we have 9/1, so we'll make that our x and y. So then setting up y equals mx plus b, our y is -1, which equals -4/9 times 9, which is our x, plus b. So in order to set up our formula, we've got to solve for b first. Okay, so what's the first thing we can do here?
Cancel the 9s.
Yeah, you got it. Again, might not always be this nice, but when it is, we roll with it.
Right.
-1 equals just -4 plus b. And now we can move that -4 over, right? So add, well, we don't add a 5. We add a 4 to both sides. All right. And then we have b equals what?
3.
Yeah. We're not done here. That's the only difference. If we use the other formula, when we get to the end, we're done. In this case here, we've got to set it up now to y equals -4/9 plus 3. Oh, don't forget our x. Any questions on that? Okay, you guys feeling pretty good? Let's move. All right, let's move on.
Can you go back, please? I was still writing it down.
Oh, there you go. And don't forget, guys, this is being recorded, so you will get a copy of this.
Oh, okay.
As soon as it uploads, I'll just need you to put your full name in chat, first and last name.
How do you get to the recording, by the way?
Oh, so what'll happen is as soon as it uploads on the cloud, I will actually send you guys an email with the link, and I will I'll send you the password in case it doesn't work, but I'm going to disable the password. So you'll be able to click the link and it should take you straight to the video.
Okay.
Great question, though.
I'm finished.
All right. Let's go ahead and move on. Okay, so this is a little bit more of the same. The only difference is how it's shown to you, how it's presented. So I'm not going to go through the whole thing just because we've gone through about 5 of those questions. But I will say, if we were looking for points, well, actually this one's a little bit different because we don't know the slope. So let's go ahead and do the first one at least. What are our 2 points based off of this? If it says t of -1 equals 4 and t of 2 equals a -4.
Would
What
it be
are our
4
points?
and -4?
I see where you're getting at. What would be more interesting is if we look at this first one right here. What is our x and what is our y? Because these are both separate. And just
-1 and -2 of our x's.
yes, yes. A really good way to think of that is that remember that our function t of x equals y. So whatever we plug in should be our x.
All right.
And whatever we end up with should be our y.
All right.
Okay. Yeah, what's gonna be key with a lot of these is knowing how to set them up. So they might be presented to you differently, but you'll end up ending up at the same location. Because this thing wants you to determine the slope-intercept equation. Well, the slope-intercept equation is this, right? That's that y equals mx plus b.
All right.
So if we have 2 points and we need to know y equals mx plus b, what formula are we using?
Slope.
Yeah, you got it. And our slope is y2 minus y1, or vice versa, minus x2 minus x1, or vice versa. I'm going to go ahead and make this our x1, y1, and make this our x2, y2. It doesn't matter which one you do, as long as you keep it the same when you write it down. So if we have y2 minus y1, that's going to be -4 minus 4. And 2 minus -1. Okay, so what do we get?
-8/3.
Yeah, because that ends up being a plus right there. So -8/3. Okay, and that's our m. So if we look at this again, we actually have y equals -8/3 x plus b. What can we do from here?
Plug our points in. You got to pick X and a Y.
You got it. Yeah. So from here, if we want to solve for b, we can just plug any one of these 2 points in. Your choice. So I'm going to go ahead and go with the first one. So I'm going to plug this one in. So if it's y equals mx plus b, it's going to be 4 equals our m, which is -8/3. Our x is -1 plus b. Remember how I said it's not always nice for us?
All right.
This is one of those, right? This is one of those where we just don't get rid of the fraction. So we got a negative times a negative. So this is just going to be 8/3 plus b. And moving it over. So then we end up with 4 minus 8/3 equals b. How do we do that? What do we
Change the
need?
change the denominator. Get the same
Yeah.
denominator.
Yeah, we're going to have to multiply that 4 by 3/3 to get the same denominator, right?
Right.
So moving this over, this ends up being 4 times 3 is?
12.
Yep, so we have 12 minus 8/3. And that's going to be 4/3.
Okay, I got the same. Okay.
Yep. So the equation of the line here, and you have to be careful because this says t of x. So we're used to writing y equals mx plus b, right? Make sure that you're writing it as what it asks for. So t of x, which is our y, equals -8/3 x plus 4/3.
All right.
It's going to be really important if it's saying that it's a function and it's a f of x, t of x, p of x, r of x, that's what you write when it wants the equation. And then the second part of this equation wants you to find t of 4, meaning it wants you to plug in a number for x and solve. So if we were solving t of 4, and I'm going to just kind of do that to kind of, let's see if I can't get a straighter line here, guys. There we go. So t of 4 equals -8/3. And since we're plugging in 4 for x, that's where that goes, plus 4/3. So what is -8/3 times 4?
-12/3.
Close. 8 times 4 is what?
Oh, 32. -32.
Yeah.
I add them. Sure.
No, you're good. And then we're just adding 4/3 to that. So what's -32 plus 4?
-28.
And there's no way to really reduce that one, guys. That's just how it goes. So -28/3 is your answer for t of 4. Make sure if you can reduce it, you do. Any questions on this one? And remember, you could have used y equals mx plus b again right here, or you could have used the point slope formula. Either one would have gotten you the same thing. So recap for this one, you've got to determine what your points are, right? From what it gives you. You're going to plug them into the slope formula. You're going to come up with your equation. And that's the first step. And then the second step is just plugging in a value for x or y, whichever it asks. In this case, it's just x. And solving for y. Everyone feeling pretty good to move on?
Yeah.
All right. Okay, and we're not going to do the second one because again, it's just more of the same stuff. This is the same. It's just doing points, and it's using the slope formula. Does anyone absolutely want to see us go through one or two of these?
Yeah. 'Cause I think I got tripped up on these one time.
All right, not a problem. That's why I ask. Yep, this review is for you guys, so if there's anyone here that wants to see one, then that means that there's probably more than one. Okay. So this one, again, you're looking for an equation. So you want the line passing through 2 points. So again, m equals y2 minus y1 over x2 minus x1. And then we eventually want to get into slope-intercept form, which is y equals mx plus b. Notice it does have a note. It says if appropriate, use x equals. So it could also be like x equals a. All right. So let's see. I'd like to do this one, and this one. So start with the first one. So we have 1, -10, and 3, -2. So x1, y1, x2, y2, right? So now it's just a matter of setting it up. So -2 minus -10 in parentheses. And then in the bottom, we have 3 minus 1. Three minus 1 is 2. What's -2 minus -10?
8.
Yeah. 2 negatives become a positive. We get 8 divided by 2, which is 4. Okay. Now, last time I showed y equals mx plus b. This time I'll do point slope. So y equals our m, which is 4, x minus x1 plus y1. Now, this doesn't mean you have to use this first set of points. This is just the formula. I'm actually going to go ahead and plug in 3, -2. Again, it doesn't matter which one you plug in, you should get the same answer. So y equals 4, x minus, and I'm plugging in x2, y2, so 3 plus -2. What's the next step?
Distribute the 4.
Yep, got to distribute that 4 to both terms. So you have 4x minus 12 minus 2, which equals 4x minus 14. And that is our equation. Y equals 4x minus 14. Any questions on that one? Okay. Now we're going to do that second one. Just going to make some room for it. And our 2 points are 7, 1 and -5, 1. Okay, so x1, y1, x2, y2. And again, guys, you could switch the labels if you'd like. That's up to you. As long as when you put them in here, you're keeping with the same points. For instance, if this is my y1, or I'm using this one first, then that -5 needs to be here to match the 1. Likewise, if I use the 1 here from this one, then the 7 needs to match it. Okay, so what happens to this one? What do we got?
0 over 0 over -5 minus 7, -12.
Yeah. And what's that equal?
That equals I mean it's 0 slope.
That is a 0 slope. What
So
happens?
undefined?
Close. So it's not undefined if it's 0. If we have the 0 in the top, it's not undefined. But I'm glad you brought that up because that's coming up next.
Right.
What this does mean though is that when we plug this in, right? What happens to this?
It's just 0 goes away.
Yeah, so we end up with just y equals b.
All right.
And what is our y value?
1.
Yeah. And notice for each of those, 1 was the y value. And that just means that it's on that line. And no matter what x value you put in there, you're always going to have 1 as your output. So y equals 1. Any questions about that one?
And that'll be a horizontal line, right?
That will be a horizontal line. Now
Okay.
we'll actually write that down.
Gotcha.
I guarantee you guys, they will try to trick you with this one. So it's really important to know which one's which.
Right.
And here's going to be why, and I'm going to do it in a different color. Let's go ahead and do this next one, which is 5, -7, and 5, 10 as our points.
Do you think you could let us do one of them and then you do it right after to see? if we're
Yeah.
getting-
In fact, if you want to do this one, go for it and tell me what you get. I'll give you guys a couple minutes.
Okay, thank you. Oh, I see what you meant. I have my answer.
All right, so let's go over it. So what did you get for your answer?
This is the one that's undefined, right?
I got undefined
Yeah.
too.
I got the
Yeah.
0 in the denominator.
Absolutely. It's when the zero's in the denominator, it's undefined. Doesn't matter what your top is here. We've got 5 minus 5 here, which means we've got something over 0. So what is our equation then?
X equals 5.
Yes. Yeah, remember how it says up here, if appropriate, use x equals. This is where we use it. And it's
Be a
going to be,
vertical.
it'll be a vertical. Absolutely. Vertical line. So horizontal line, y equals, your slope is 0. Vertical line, x equals undefined. Any questions about that one? Okay. We're going to go ahead and move on. This is a good one.
Yeah.
So you were given this function and it says it has one local minimum and one local maximum. And it says to graph the function on your calculator. What I'm actually going to do is I'm going to pop up Desmos. And then we'll just go back and forth in answering the questions. So what I am going to do really quick is write it down. So that way, when I switch screens, the writing is still there.
Will we be able to use that on the test?
That depends on your professor.
Okay, yeah, because I hope so, because Desmos is very useful.
Yeah, she allows us to use. Well, wait, we all have the same teacher, right?
I don't think so. Nah,
No. So this is open to yeah, this is open to everyone that's in MAC 1105C. So your professor might be different. But I do know that for 1105C, most, if not all of the professors did embrace Desmos.
Yeah. Well, if you have Hannawell, she allows you to use Desmos.
Yes. All right. So if we're plugging this into Desmos, I'm just going to go ahead and do y equals, okay? And it's going to be good if I actually type in the whole thing. So 2x cubed minus 6x squared minus 90x. That's the Windows button. X minus 4. Okay, and as you can see, I'm a little zoomed in, so I need to zoom myself out.
All of them, right?
And so now this is graphed, right? Let's go back and see what the questions are. So it wants to know the local maximum and the local minimum. Okay.
Right.
So what's nice about Desmos is you can click on it and it gives you the points automatically of your local maximum, minimum, and your zeros.
Wow.
And where it crosses the y-axis. So anything you need to know. And you can just drag the graph.
Talissa, you're not muted. You're not muted. I'm sorry. I just can't hear him.
Here, let me see. I'm going to do that. And then those of you that are participating can now unmute yourselves. Okay. So clicking on this. Now, which point is this? Is this our minimum or our maximum?
That's our minimum.
You got it. That is our minimum. And I'm going to go ahead and write down the point. Which I have to. Okay, so our point is 5, negative 354. which numbers are actual minimum?
Is it the 5 and the negative 354?
Yeah, so the thing that you guys are going to want to remember, and if you have a lot of stuff going on in the background, could you please mute yourselves when you're not talking? Thank you. What you got to remember about the maximum and minimum is that the maximum minimum is the y value, and it happens at the x value. So when you're asked for the maximum and minimum, you want to give the y value of that point. So for this one, our minimum is what?
5.
Careful. Which one's our y value?
Negative 354.
Yeah. So our minimum is negative 354
At 5.
at x equals 5.
Right.
And that's usually how it shows. And when we switch back, we'll see that. Okay. And then scrolling up, let's take a look. Whoops. Yeah,
Hey,
be
Danny?
careful. Yes.
Why did we choose that point? Was it because it was? Yeah, I'm not gonna act like I don't know. Why did you
It's-
choose that
oh.
point?
That's okay. So let me ask you, is this point here, is this area here, would you consider that our maximum?
Oh, okay, no.
Right? So you see how this point is already there?
Yeah.
Desmos is really nice, and when you graph in Desmos, it automatically gives you the points at your maximum and minimum.
Oh,
as
okay,
long
so
as you
that's the maximum and the bottom is the minimum.
Exactly.
Okay.
As long as you recognize where your maximum and minimum are, then you can find them on Desmos. So scrolling out a bit, as you can see, this graph's really crazy. If we recognize this right here as our minimum
That's a
and
good
we
ass
click it,
question. There's no way we're having a brunch at the spot.
I don't think so. I just have to spawn so include their damn hotel.
I'd rather go to IHOP.
They need to fucking like cookies.
Something.
please mute yourself if you're not talking about math. Okay, so our maximum here is what?
158.
Yes, and it's 158 at x equals,
Negative 3.
yep, and I'm gonna go ahead and write that. So our maximum is 158 at x equals negative 3. Okay, so sorry, whoops, there we go. If we switch back to this, so our local maximum here would be 158 at x equals negative 3. Our local minimum would be negative 354. Make sure you put the negative sign at x equals 5.
Right.
Okay. Now, yes.
Did you say that the top of the line is the minimum and then the bottom is the maximum?
No.
What do you think?
So it'd be the bottom is maximum.
No.
So let's take a look, and let me see if I can't fix this graph real quick to make it so that, let's see. Now let's do 5. And okay. All right. So if we're looking at this, and I know this is really, let's see, 2, 1. Trying to kind of just spread it out a little bit for you. Okay. So what this essentially looks like, and I know it's hard to tell on this particular graph, what it essentially looks like is it goes like this, right? Just really tighten it together. Let me see if I can't try that a little bit better. So our graph essentially goes like this. Okay. Of these 2 points, which one is our minimum and which one's our maximum? And actually, to differentiate, I'll make one blue. So which one's our minimum, the red or blue?
The blue.
The blue is. And it's considered a minimum because it's a minimum point. And the graph goes up, right? It's a lower point, so it's the minimum. And remember, since we're dealing with y values, if you look, our minimum point is a really small number. It's a low number, negative 354. Whereas our maximum point, 158, it's a really high number. So it's talking about minimum y values and maximum y values. So when you think of min and max, kind of associate it like that, and that'll help you decide if it's down here, it's most likely a minimum. If it's up here, opening down, it's a maximum. Okay, like right, maximum. Another good way to think of it is if you're dealing with like y equals x squared and y equals, say, negative x squared. And I will hide this one. So if we're looking at x squared, right? This point right here, is that a maximum or a minimum?
Oh, minimum.
It's a minimum, right? It's the
Right.
lowest possible y value for
Right.
this function. It's the minimum y value. Now, let's take a look at negative x squared. Is this point a maximum or a minimum?
Maximum because it's the highest. You just turned it
Yeah.
around. Right.
Yeah, it's the highest. So that's a really good way to gauge it. And I hope that answered the question of the person who had it. Okay, now the next thing that this asked for was increasing and decreasing intervals. What's really important and what plays a role here is our minimum and maximum. So as I said before, our graph looks like this little N, right? Starts at the bottom, works its way up, goes down, works its way up. So
Right.
where are the intervals of it? Where is it increasing? Where is it going up on the graph?
From negative infinity.
Mm-hmm. So increasing from negative infinity, where's it stop?
At 158 at the max.
So it
But-
stops at the maximum, but we're
Right.
dealing with x values.
Right.
So what's the x value at y? Y is 158.
Negative
Infinity.
3.
Yeah, it's -3. Right? That's why
Right.
it's really important to write this stuff down or recognize it, because again, we're dealing with x values when we're talking about increasing and decreasing.
Right.
So this kind of helps us set our boundaries of where stuff starts and stops.
Right.
Does it pick back up again for increasing?
Yes.
It sure does. Where?
Let's see. At the minimum of 5.
Yeah, right at x equals 5, it picks back up and goes up again.
Right.
So we got to union that, and we said it starts at 5. Where's it go
Right.
to?
Infinity.
Yeah. And if you zoom out of this graph, you'll see it just keeps going forever, right?
Right.
So it's going to go up here, stop, and it stops increasing there. And then from our minimum all the way down here, it's going to increase again. All right, so where's it decreasing then?
From the maximum from -3
Mm-hmm.
to 5.
Yeah. And you guys can see that because it's just what's left on the graph, right? And it's going down. So it's in between those 2 points. So if we are looking at putting that in, this is -infinity, comma, -3.
Mhm.
And then we're going to use the interval to union it with 5 to infinity. And then this one is just -3, comma 5. Does anyone have any questions about that? I know that graph was a little hard to see on Desmos. And if you're using a graphing calculator, you definitely have to tweak your window quite a bit to see it.
Right.
I have a question.
I have an answer.
So when we take our exam, we use Arnold law. So I'm not sure if we can use decimal. So is it a way that we can like solve this equation to where we can get the minimum and the maximum?
Yeah. So well, for this one, you'd have to use a graphing calculator. Now, if your
Okay.
professor allows you to use Desmos, even with honor lock, you can get Desmos on your phone. So that's an option. But the other thing is that if you have a graphing calculator, you can actually find a maximum or minimum on your graphing calculator. And I'm going to just tell you. So the buttons that you'd press is you do the y equals button, right? And you would type in your function. And then you would hit graph. To get the window so you could see it, you'd have to hit zoom and then zoom fit. And this is on a TI 8384 calculator. And then you would do, to find the maximum or minimum, you'd hit second and then calc, which is actually the trace button. And then you would choose a left bound and a right bound of each one. So like your left bound would have to be like on the left side of it, and your right, and then you'd hit enter, and then you choose a right bound and hit enter, and then it'll say guess and hit enter, and it gives you the points. And when you do this part for the calc, you're going to choose whether it's the maximum or the minimum. So you'll have to find each one separately.
Okay, thank you.
No problem. Yeah, like I said, it's up to your professor. If they let you use Desmos, like I know Hannawell does, I know Mace does, then you're pretty golden. But you can use it. You can find it on a graphing calculator as well. Just, takes knowing the buttons. Okay. Any other questions about this one? Because I know that this one was a lot.
Yes. How did you find at x -3 and at x 5?
Yeah, not a problem. So if we're going back, remember that this is a point. Okay. So if we're remembering that this is a point, what is our x value here of this point?
5. I see.
Yeah. And notice that that's where our minimum's at. So that's how that works. All of these are their points, and you've just got to know that the maximum is the y value, and where it occurs or where it happens is at the x value. And if you submitted, you'd get it right. All right. Good job. And moving on. This deals with perpendicular and parallel lines. I don't want to go through finding the entire equation just because we've spent a lot of time on linear equations as it is, and there's a lot more to this section. But I do really quick when I go through, if I have a -3/2 slope, what is my parallel slope to it?
-3/2 again.
Yeah. And if I have a -3/2 slope, what's my perpendicular slope to it?
2/3.
2/3. Yeah, just remember, if it's parallel, it's the same exact thing. If it's perpendicular, it's the opposite reciprocal. So you're gonna flip it and you're gonna change the sign.
And we would do like the y equals mx plus b thing.
Yep. Then from here you do the y equals mx plus b and plug in your point and solve for b.
Right.
Find your equation.
Right.
And then I will say, actually, I will say this one for x equals 11. What's the slope there?
11/1. What, 11? I
No.
guess.
So if I want an equation of a line that's parallel to x equals 11 and
Right.
it passes through this point,
Right.
first off, what kind of line is x equals 11?
The slope would be 0.
Oh, it had. Oh, I get it. I get it. No, it has. It's a vertical line. It's a vertical line because it's x
Yeah.
equals 11. Gotcha. I want to think.
Yeah.
Right.
Yeah. So this might be a tricky one, right? So just
Right.
remember, this is a vertical line. So if it's asking for a slope or a parallel slope, it's undefined,
Right.
which means if you're looking for an equation, you're looking for an x equals. And what would our x equals be here?
0. But undefined.
Has to pass through this point.
Oh, -9.
There you go.
Right. X value.
Now, what about perpendicular?
I don't think that one.
If it has to pass through this point and it's perpendicular,
7. Y equals 7.
yes, y equals 7. And the reason why, this is our y value. This is a vertical line. Wow, that was not straight whatsoever. Let me try that again. This is a vertical line that passes through the point -9,7. If we want a horizontal line to pass through that point, then it's got to be using the same value, right?
All right.
Yeah. Does anyone have a question about that one? Because that's the one that's really tricky. All right.
I have a question.
I have an answer.
So you said for the first one that it's a vertical line
Yes.
and the second's horizontal?
Yes.
Okay.
All right.
Yeah, guys, remember if it's x equals, it's vertical. If it's y equals something, it's horizontal. So this is dealing with x, and this is dealing with y.
Is it vertical because it's a parallel line? It's asking you.
Yes, because it's asking for a parallel line to x equals 11.
Okay.
And it has to go through this point. So that kind of gives you when it says it has to pass through that certain point, that point's going to be the key to finding what the equations are. Did that answer all your questions?
Yes.
Awesome. Okay, let's go ahead and see what's next. It's the same thing. Yeah, so let's talk about this one because we talked about maximum minimums, but now you're given a paragraph of text,
Yeah.
right? So Sunglass Hut Company has a profit function given by this equation. What kind of equation is that, by the way?
Look, quadratic.
Yeah, it is.
Okay.
Good catch. Yeah, that square there means it's quadratic. Q is the number of thousands of pair of sunglasses sold and produced, and P of Q is the profit in thousands of dollars from selling and producing Q sunglasses. So if we have our X and Y, this is saying Q are the sunglasses
Right.
and P of Q is the money we make.
Right.
So if they want to know how many pairs of sunglasses should be sold to maximize profits, what do you think we're looking for?
We need the I want to say we need the slope, but we kind of have it.
So there's no slope defined here because it's a quadratic, right?
Okay.
I mean, don't get me wrong, there's slopes defined, but it's not
Right.
like
Yeah,
the slope of a line,
got
right?
you.
We're not looking for like a y equals mx plus b.
Mm,
But if we want maximum profit,
right.
remember the keyword maximize.
Oh, we look for the max. The max.
You got it. Yeah. So if they say we want to minimize costs or maximize profits, you're looking for the maximum or the minimum, and that's going to be your keyword.
Right.
So what I'm going to do is I'm going to pop this equation into Desmos so we can take a look at it. 0.01 x squared plus 4x minus 38. I'm going to have to zoom out. Okay. So this is our quadratic function. And if we want to maximize profits, what are we looking at?
The maximum.
Yeah, and what numbers are those? So which one's the maximum?
The x value. So 200.
Ooh, careful.
Oh.
Which one's the maximum?
Oh, the high is the y. 362. 362.
There you go, 362, and it occurs at x equals 200.
Right,
So I'm just
right.
I'm gonna write that down. It is very interesting going back and forth between annotating, guys. All right, so it's 360, so it's 200. 362 was the point. So the maximum is 362 at x equals 200.
All right.
Here's where you guys got to be careful with these word problems. This says in thousands of dollars and in thousands of pairs of sunglasses. So if we say how many pairs of sunglasses should be sold to maximize profits, and this says 200 for 200 sunglasses, it's really 200,000. Okay. Because it's in thousands. So whatever number you have, you got to tack 1,000 onto it. So for instance, if it says what are the actual maximum profits, again, it wants to know what our actual maximum is, then that would be not 362, but 362,000. Unless it says thousands of dollars. If it doesn't though, you write in the whole thing.
Oh, I see. I thought it would just be 200. Oh, we gotta change it into
Yeah,
money.
yeah, that's
Okay.
That's the key with these word problems is you have to be careful.
Okay.
Any questions about this particular word problem? Okay. And again, a lot of the word problems are like this, where you're looking for a specific thing, maximum or minimum, especially if it's a quadratic. And you just got to be careful on how you're answering it.
Gotcha.
Okay, this is a long one. So slope of a line has a meaning, which is how much the y value changes with the x as x is increased by 1. So let's see. So they want you to read the problem below and identify what the slope is along with its units. It's important to compare the total cost of a cell phone plan, including the cost of phone. One company charges $71 for a phone and $68 per month for unlimited talk and text. What is the slope? So if we're looking at this based off of what they gave us, if it's $71 for a phone and $68 per month, what's the value that never changes?
Oh, the value that never changes is the $68 per month. I mean, no, that's per month. I mean, the company charges 71
so-
for the phone, 71 doesn't change.
Yeah, so think about this one. This one's saying one company charges you 71 for a phone
Right.
and 68 per month for unlimited talk and text. So what's the slope?
68x.
Well, do we need the x part?
No, because it's just 68 per month.
Right. Well, and remember, we're dealing with slope, so the slope
Right.
is just the m.
Right.
Okay. All right. And what are the units of our slope?
Dollars per month.
Yeah. I know that one's like a lot really wordy, right?
Right.
Does anyone have any questions on that one?
That's all you have to do for that one?
Yeah.
Wow.
But like, notice like there's like all this text right up here, right? Where did my thing go? Keep having to drag my thing over here. There we go. Yeah, so when it's talking about this, right, all of that is explaining about pointing out the slope in word problems and what the slope represents. And then this is the actual question. Okay. Oh, right, I can't click. There we go. Oh yeah, domain and range. Okay, let me bust out my annotation. Okay, so domain and range is another big one you guys did, right? So if we're looking at this particular equation, what is the domain?
The domain. That's the x's. So bracket -2 to positive infinity.
Oof, careful. So you were definitely on the right track. And you were rocking it. So as you said, it's the x values, right?
Right.
So where does it start?
At -2.
Definitely starts at -2 right here. And it's
Right.
solid, so we do include that. Where's the,
Oh, at 3.
where's it? Yeah, it ends right here at 3.
It threw me
right?
because of that open circle, so I didn't know if that counted as it stopped. Okay, got you.
Yeah, so the question is, since that is an open circle, does it include 3 or no?
It does, but it doesn't stop. I mean, it does. It isn't solid. Like it could be something else. I guess that's what it's saying.
What it's saying is that it gets really, really close to 3, but
Right.
doesn't actually hit it.
Right. Right.
So if it's open circle, it does not include 3, but it could
Right.
be like 2.999999.
Right. Right.
That'd be okay. But it won't be 3.
Right.
So that's when we get our parentheses. In fact, what I think what I will do is I'll actually type this one. And for this one, you'd have to come here, right? -2, 3. Okay. How do we write that in set builder notation?
Yes. So put -2 because I had
Mhm.
is greater than or equal to
Careful. If it starts at -2, it's not -2 is not greater than, right?
right.
X can be greater than.
Right. Right.
So it's less than or
Less
equal
than.
to.
Less than equal to, yeah.
And then we have our X,
Uh-huh.
right?
Uh-huh.
And where's it stop?
At
Less
3.
than 3.
Yeah.
Yeah, less than 3.
Right.
Okay. And
I need to write that.
if you're not sure, number lines are your best friends, guys.
Right. Right.
Oh, where did my trying to find my there we go. Number lines are your best friends. So if you have -2 and you have 3, that was a closed circle and that was open, and it's everything in between.
Right.
Okay.
But you good though?
Yeah.
So you good?
Okay.
Mm-hmm.
Now, how about our range?
The range is so the lowest to the range is
Yeah.
-5
Okay.
Yeah.
-5.
You see, I like you.
open -5 to a
Okay.
closed 4.
Yeah, you got it, because that's usually the tricky one. So remember, when it stops here at 4, that is a point that's on the graph. So even though it's not like a closed or open circle, it still counts. Very good. So this would be, and let me bust out the interval for it. We'll do this one. -5, 4. And how would we write the range in set builder?
-5 less than
Oh, so by Thursday,
then you
Okay.
put
Good.
the X.
Careful.
Why?
Why? Because it's range. Yeah.
Right. Why? Greater than or equal to 4.
Less than or equal to 4.
Oh, less than 4.
Okay. And you check it, and you're golden. Any questions about this one? And please remember, if you haven't already, to put your full name in chat.
Oh, yeah.
Thanks. Okay. We're going to go ahead and move on then. This is another function increasing, function decreasing.
Mm-hmm.
So if we're looking at this, where's this function increasing? X values wise.
X values is going to be negative infinity
Okay.
to about, I want to say -2.5.
Yeah, definitely. -2.5.
Then we're going to union to 1
Mm-hmm.
to positive infinity.
Yeah. And for those of you trying to see it, as you can see, it's increasing up here, stops here, and then it picks back up right here and is increasing again. All right, how about decreasing?
It decreases from that negative 2.5
No.
to
What?
1.
Yeah, good job. Yep. Okay. Sorry about that, guys. But yes, that is how this works. And of course, remember when you're talking about increasing and decreasing intervals, nothing is included. So you're only using parentheses. Now, looking at this, what is our domain?
Our domain is negative infinity to positive infinity.
You got it. Yeah. Whenever you see a graph like this where it just kind of goes off, expect that it's going on forever unless it says otherwise. Good job. All right. Oh, we got to do one of these. You guys seen this, right?
Right.
I never understand the second one. I always get the second one wrong.
Well, hopefully we can fix that because this one in particular is a doozy, so it's perfect
Right.
for us. All right. So, first off, writing down what we know that f of x is negative 6x squared plus 3x
Right.
minus 6.
Right.
So if we want to find f of x plus h, all I'm going to do is everywhere there's an x, I'm going to just kind of leave the brackets open for a moment.
Right.
Of course, it'd be nice if I wrote down everything correctly. Super important. If you make the mistake I just did, it could change everything.
Right.
Okay, since we're plugging in x plus h, we're plugging in x plus h. What is our next step here?
Distribute the negative 6.
Ooh, can we do that with that squared?
Oh, I meant 4. I meant 4 to for that
Foil.
square one out.
Yeah. Careful, guys, here. Whenever you see this squared, remember that this is x plus h times x plus h. So we got a FOIL. So x times x is x squared. X times h, xh. H times x is also xh because they're switchable. And then h plus h is h squared. Okay. Or x squared plus what? What can we combine here?
X plus, xh.
Yeah, so how many are there?
2 xh.
Plus h squared. If you can remember this, then that's awesome. But if you can't, it's okay. You can work it out. And showing our work is sometimes really good anyway, right? Just to show that we really know something and aren't making mistakes. So what else can we do now? Now that we've foiled that out.
Now distribute.
Now distribute. So let's see, we got negative 6 x squared, right?
Right.
Negative 6 times 2. So we've done that. What's negative 6 times 2?
Negative 12 xh.
Yep. Okay, and then here, negative 6h squared.
Right.
And then we're going to go ahead and distribute that 3 as well.
Right.
So we get 3x plus 3h minus 6.
Right.
Is any of that able to be combined?
No.
No. So if you end up with something long like this, don't worry, you've done it right.
Do they
But we're
want us
not-
to factor out the 3 or just leave it as is?
Leave it as is.
Okay.
If you factor out the 3, then that's going down a whole different can of worms. You
Gotcha.
don't worry about that.
Okay, good.
So yeah, so this is our answer. It's that negative 6x squared minus 12xh minus 6h squared plus 3x plus 3h minus 6.
All right.
Now for that doozy of a second part. Now
Okay.
we're taking our f of x plus h. We're subtracting our f of x all over h.
All right.
Okay. So if we're doing f of x plus h minus f of x all over h, let's write this out. So what is our f of x plus h?
Negative. The problem we just did, right?
Yeah, it's that really long one, right? So we
Right.
got the negative 6x squared minus 12xh minus 6h squared plus 3x
Right.
plus 3h minus 6. Now guys, be really careful when you're doing this part and it says you're subtracting f of x, make sure that that is in parentheses. Okay? Because you're not subtracting just like, a number or something. You're subtracting an entire function. So you're going to have to distribute that negative. And our f of x is negative 6x squared
All right.
plus 3x minus 6. All of this, if you can draw a straighter line than me, is over h. So remember what I said. We have this negative here. It needs to distribute to every term. So this will become positive, this will become negative, and this will become positive. Do you guys see that? So if we rewrite this, don't change anything in the beginning, plus 3x plus 3h minus 6. This becomes a plus 6x squared minus 3x plus 6. Again, all over h. Now, is there anything there that you guys see that you might be able to cancel out?
A lot.
Yeah, what's nice
Yeah,
about these?
I'm lost.
Okay,
Oh
where
no.
let's see if we can't find you back on that path. Where'd you get lost?
Okay, so you know how you're
Oh.
supposed to fill in like what we got for the first answer into the second problem?
Mm-hmm. Right here?
Yeah. So like, okay, so you know how you have to plug in F in the parenthesis X part, like the X part?
Mm-hmm.
Okay, so where did you get that from? 6x squared plus 3x6. Like, why did you plug that in?
What is our f of x?
Oh,
Right.
Yeah. So if you look and you can compare these two right here down below where I've written them, our f of x is this really long thing, right? Or our
yeah.
f of x plus h. Our f of x is the shorter one. That's where we built this whole thing from. So now it's just bringing it back.
Okay.
Does that make sense?
Yeah.
Okay. So what can we combine or cancel out?
My bad.
You're good. So what can we combine or cancel out, guys? How
Can we
about
do
the
negative 6 and 6?
yeah, negative 6 and 6. Good call. Anything else? What else?
Positive 3 and negative 3x?
You got it. What else?
Negative 6x and 6x, both of the negative 6x squared.
Exactly. And guys, let me tell you, whenever you're doing these, you should always be able to cancel out these last three terms
Right.
with something from the big one. Okay. That is always the case. So if something happens and you can't, then you know you need to maybe go back a step. So what's left over? Negative 12xh minus 6h squared plus 3h all over h. From here, there's a couple ways you can handle this. What would you do first? Give me a couple options here. Well, what do we do next? Is there anything we can do next?
Oh, the H. The H.
Yeah. So one of two things you can do. Okay, and I'm gonna do like method 1, method 2. Method 2 is you can factor an h out from the top, right? So if you factor an h out, you end up with negative 12x minus 6, h plus 3. You guys see that? All over h. Or you can separate them and just make sure that you're putting each one over h. Okay. Both of these methods work because what's the next step?
Cancel 'em.
Yeah, getting rid of the h over h because it's anything over itself is equal to 1, right? So what are we left with?
Negative 12x minus 6h plus 3.
And that's your answer. Negative 12x plus 6h minus 3. Does anyone have any questions about this one? Any more questions? Feeling a bit better about this one? All right. Okay, let's move on then. Something else you guys did, one of my favorite things is composition of functions.
Right.
And in this case, you're given this is f of g of x, and you've got to find what f of x and g of x are.
Right.
Whoops. So something that I like to do with this is anything that you see that's like in parentheses, pull that out.
Right.
Okay. So what do we see that's in the parentheses?
X minus 2.
X minus 2. And what we're going to do is we're going to say that that's what we plugged in. So our g of x is equal to x minus 2.
All right.
If we pull out that x minus 2, what we're left with is this. And whenever you
Right.
have something empty, throw an x in it.
Right.
And that's what you're left with. So that's what your f of x is.
Okay.
And of course, you don't really need the parentheses after that.
I noticed on that one, it said you can have a lot of answers. Could you have put 1 over x to the 5th, or that would have made you wrong because of the 8?
It would have made you wrong because of the 8.
Okay, gotcha. So you gotta include the 8. Gotcha.
Gotta include the 8.
Gotcha.
Yeah, there are a lot of possible answers. Doing it this way, though, seems to be the most consistent.
Right.
from equation to equation
Right.
because they do get different. For instance,
Wait, can you put that back really quick?
oh yeah. Yeah, I was gonna look for one that was similar to it. Let me know when you're ready.
Ready?
Cool. Let me find, because there should be. Well, we definitely need to do that one. Maximum, minimum, maximum, minimum. I knew I saw another non-trivial. Where was it? No, maybe not. Maybe what I'll need to do is just I'll just type it in. So we decide for 8 over x to the 5th, right? 5th.
Right.
And then x minus 2.
Yeah.
Okay, get some more. Oh, it's not gonna give me another one. Let me throw one at you guys.
Okay.
We'll just do it that way. I was hoping it would give me one that you'd probably more see. So if you have like x minus 3 over x plus 2, and this is f of g of x. Okay. What could we pull out of this square root? And I
X
swear that's
minus
a square root. It is.
X
let me
minus
fix it.
3 over x plus 2.
Yeah, so if you notice, you could put that whole thing in parentheses, so you could pull that whole thing out. X minus 3 over x plus 2, and that can be our g of x of what we plugged in, which means our f of x is what?
Square root x.
Of it. Good job. And again, for this one, like you wouldn't really be able to pull out like just like an x plus 2. I mean, you could, but then you'd really have to configure what the top looked like, and that'd be really weird. It's just easier to plot the whole thing. Okay. I'm gonna go ahead and
Can you go back, please?
yep. Bam. I love this back button, this undo. It's great. You done?
Yes.
Okay. All right, let's go ahead and move on. Now, technically, we would be out of time, but if anyone is willing to stay after, I'm gonna just do a few more to make sure we cover everything, and that's gonna be on the recording as well. So please feel free to stay with me.
The rest of it will be on the recording.
I'm not gonna do the entire test review, but I am going to be I'm gonna do a couple more problems that you guys are definitely gonna need to know.
Okay. I have to go, but I'll definitely look at the recording of
Okay.
the next couple problems that you do.
Make sure your full name's in the chat.
Okay, I'll type it again just in case.
Okay. This is another maximum minimum. Here we go. Here's what I wanted. So now we're dealing with more function composition. So the other one was pulling non-trivials out of one that's already composed. This is composing one. So if we want f of g of x, we want f of g of x. And I always like to change it from this format to this one, just because it's in my opinion, easier to understand. So if we have f of x equals x squared minus 5x plus 8, then f of g of x is going to equal, oops, that squared minus 5, that plus 8. You guys see it? And what is our g of x? For those still here.
Oh, we got to plug in, yeah, G of it.
Yeah, so we got to plug in x plus 6, right?
Right.
So everywhere where we saw a parenthesis, we're going to put in x plus 6.
Right.
And I swear I'll fix that, that x right there. There we go. Okay. And then again, this is one of those ones where you have to FOIL.
All right.
Okay. X times x is x squared. X times 6 is 6x. Plus x times 6, which is 6x. 6 times 6 is 36. So you end up with x squared plus 12x.
That's 36.
Plus, yep, plus 36. And then don't forget everything that we have back here, right? Negative
Yeah.
5 times x and negative 5 times 6.
Right.
So negative 5x minus 30.
Yeah.
Plus 8.
Yeah.
And now it's just a matter of combining, right?
Right.
So we got 12 minus 5.
Right.
Which
7x.
is, yep, plus 7x. And then we have 36 minus 30 plus 8.
Give us 14.
Yep, 14. And that's our answer. Any questions about that one? Okay. Am I good to clear it?
Yep.
Almost finished.
So, one
Oh,
second.
he ain't done. Okay.
Okay.
Sorry.
No, that's why I asked, because if
I was trying to unmute real quick and it wasn't unmuting.
you're good, you're good. I got you guys.
So for the problem, the f is that f times g in the parentheses.
That is f of g.
Okay.
So you're plugging g of x in for every x value in f. So everywhere you see an x here, you're going to plug in this. And that's how that works.
Thank you.
No problem. You guys good? I can clear it now?
Yes.
Okay. And thank you for speaking up when I was too quick on the draw. We've done that. We've done that. Oh, let's talk about this one. Symmetry. Usually when we're talking about symmetry, you guys are looking at a graph and deciding whether or not it's symmetric, right? And we've got it with respect to the y-axis, the x-axis, and the origin. But for a moment, let's think about a point on a graph. Let me see if I can, there we go. Okay. And let's figure out what point would be complementary to it to make it symmetric. So if we have 16, 18, which is, we'll just say right here. Okay. And we say that it's symmetric. It's on a graph that's symmetric with respect to the y-axis. What is the point, the reflective point of 1618 to make it symmetric with respect to the y-axis?
Symmetric to the y-axis, that mean the y is gonna stay the same, but the x value will flip.
That's right. Yeah. So for it to be symmetric along the y-axis, it's
Mhm.
got to be able to fold along that line, right?
Right.
So y-axis. Which means that our point should be right here on the other side.
Right.
So that 18 will stay the same. Good job. And our x becomes negative. Okay, now let's look at, we have 18, negative 12.
Right.
So 18, negative 12.
Right.
And we want to know a graph that's a point that would make it symmetric with respect to the x-axis. So
Right.
again, if you fold it here,
Right.
it would be the same.
Right.
So what's that point?
We need the same x, so 18, and then the y will change. So 18, 12.
You got
y
it.
flips.
18, 12. Yes, the y changes. And lastly, we have the point -5, -2. Okay. And we want one that's respective to the origin, which means that if you actually fold it like this,
Right.
along this green line,
Right.
y equals x,
Right.
it'd be the same. Or right.
Right.
So what is going to be the symmetry with respect to origin? And I believe another way you can do this is you flip it over the y and then flip it over the x, or you flip it over the x and then you flip it over the y.
Right.
So we can take this in 2 steps. I'm cool with that.
Right. Both values gonna change over the origin. Both the x and the y changes signs. So yeah, we gotta flip it. So the x is 5, and then the -2 becomes 2.
Yes. I lost my point here. And then yes. So if you flip it here, right?
Right.
And then you got to flip it again, you're going to end up with something right here.
Right.
5, 2. If you flip it here, you then still have to flip it again. So you end up at 5, 2. Good job. Any questions about this one? I know this one's a little bit weird because it's different. It's
Yes,
talking
the
about
last part
points.
with the 5, 2. You confused me with that.
Yeah. So when something is symmetric about the origin, it actually has to deal with the y equals x axis. Or in this case, what they've done is they've reflected it across the x axis and then reflected it across the y axis. So say I had a circle that was right here. Okay. If I reflected it here and then reflected it here, that would have to be another point on the graph. Really good example. Actually, this is an even better example. Here we go. I have this circle, okay? If I fold this, say this is on a piece of paper, if I fold it in half along the y-axis, It's the same on both sides, right?
Yes.
If I fold it in half along the x-axis, it's the same on both sides, right?
Yes.
If I fold it in half along this axis, the y equals x, is it the same on both sides?
Yes, I think so.
Yeah, absolutely. It's a circle, right? So all this is saying is that if you have this point here, and we'll say that this is our -5, 2, then you also have this point here, which is 5, 2. In
Okay.
order for it to be symmetric with respect to the origin.
So the answer would be 5, 2, right?
Yep.
Okay.
And the difference here, right? And this was brought up when we talked about it. If it's symmetric with respect to the y-axis, then the
X change, X flip.
x changes if we want to have the same point. If it's symmetric with respect to the x-axis, the y changes. If it's symmetric to the origin,
Oh, change.
both change.
Okay.
Okay, that's the key there. All right. Any other questions on this one? And we will do another symmetry one with actual graphs to kind of help you.
Yes, yes, that's the one I need.
Yeah, we'll do the graph one.
Yes.
I just wanted to go over the point one because the point one's tricky.
Yeah.
All right. So let's find the graph one. We did that. We want this one. Okay. So we're gonna look at these and we're gonna decide whether they are symmetric with respect to the x-axis, the y-axis, the origin, or none. So if we look at this one, this very first one right here, is this symmetric with respect to the x-axis?
No.
How about the y?
No.
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 How about the origin?
No.
No.
No. No, this one is not symmetric at all.
Right, because it's out to the side.
Okay. How about this one?
ES to the Y
Yes.
axis.
Yeah, right? If we fold it in half along the y-axis, we're going to get the same thing on both sides.
Right.
How about this one?
Yes.
It looked like the Y, but I don't know because all them curves in it, but it looked like the Y to me. I don't know.
It's weird, right? Let's
What about the X?
let's take a look. So if this is the y-axis and we flipped it, it would be like this. It's not going to be the same points, right?
No, no.
Mm-mm.
If we flip it with the x-axis, it's going to be like not quite the same either.
Right. So none of the.
Yeah, I know those. And it's all because of placement.
Right, right.
Oh.
Placement is everything. Now, how about this one?
All of them.
Yeah, if we fold it in half on the y, it's going to be the same thing, right?
Right.
We fold it in half along the x. Well, I switched these when I was talking. It's going to be the same thing.
Right.
And if we flip it and then flip it, it's going to be the same thing.
Right.
Okay. There's how about this one? I was hoping this one would show up. So this is what we saw earlier, right?
Right.
But now it's centered on the origin. So we know from drawing it, it's not symmetric with respect to x or y.
Right.
But what about the origin?
Yes, now it is because they lined it up right. Yeah, you can see it now. Like that 2 and then you go to -2, and then if you see -3, you can go to the other side, and it's gonna hit a point at 3 as well. if I-
Absolutely. Absolutely. So this one is definitely with respect to origin.
Right.
Okay. And then this circle is not centered. So is it going to be symmetric on all of them?
No,
No.
No. Which ones will it be symmetric with?
it looked like the
The
Y.
y-axis.
Yeah. Just the Y. Okay. And how about this one?
No.
No.
Yeah, no.
No. Because it's not centered on any axis.
Right.
And that's kind of half the problem with that one.
Right.
How about this one?
Same thing, like you said, it's not centered.
Yeah. Okay. How you guys feeling about symmetry?
Not bad. That one was messing me up right there. Yeah.
Yep. Yep. This is the next one we're doing, and then we'll have to and then we'll call it.
Okay.
But yeah, this is the other one. Okay. So if we have this graph and we want f of x plus 1, where are we shifting the graph?
To the left 1 point.
To the left 1 point. So if this is at -4, we're going to start at -5.
Right.
And again, we're just doing everything to the left 1.
Right.
Okay.
That mean the
Now-
Y staying the same? I'm sorry. We only
Yeah.
Okay.
Yeah,
Okay.
all the y's stay the same. So remember, this is just dealing with the x, right?
Right.
We're not shifting it up and down. We're not flipping it, nothing like that. This is just moving everything to the left 1. How about this one?
Not moving it at all.
So this one, remember f of x is y, right? So think of this as all the y values are changing. So if it's 0, that's still 0. What about this right here? What's this become?
Oh yeah, we're reflecting the Y. So that's still 0 because the Y is 0.
Mm-hmm. But what about this y? This y is 3.
So we're
this
going
one-
-3.
No,
That's
negative
right.
3.
And then this one's -2. So what's it actually become?
2.
There you go.
Cool.
And that's it with this. And then of course this one moves it to the right, right?
Right.
X -3.
All right.
And what's this do?
That's reflecting the X.
Yeah.
Okay, cool.
So if this is
Ooh.
-4, it's now
4.
mhm. And if this is usually -1, it's now.
1.
And if this is usually 2, it's now.
-2.
Okay.
Y doesn't change, X is changed. Okay.
Yeah. Y doesn't change, X's change.
And Y don't change there either, right?
Y don't change here either. That's correct.
Gotcha.
We're just, what are we doing with this one?
moving it to the right 3 points.
Yep. So 1, 2, 3, starting here. And then going up 1, 2, 3. 1, 2, 3. Feeling pretty good about that stuff?
Yeah.
Mhm.
Okay. Well, oh, shoot. I did say that was the last one. Let me do this one really quick.
Okay.
This one's easy. This one's quick and easy, I promise.
Okay.
Like I know all the others have like several parts. This one doesn't.
Okay.
If you're given this and they want to know what the vertical intercept and the horizontal intercept are, what are we solving for?
X and Y.
Yeah.
So remember vertical is the y-intercept.
Right.
Horizontal
X.
is the x-intercept.
Right.
If we're given this, what are x-intercepts?
1.
Ooh, careful. So you have
Oh.
x -6,
Oh. Yeah, the
x
opposite.
+1,
Gotcha.
x -2.
Right.
So your x is 6, -1, and 2.
Okay, so
remember-
work them out.
These are, yeah, but these are intercepts. So
Right.
it's 6, 0, negative
Mm.
1, 0, 2, 0. If
Right.
it just wants the zeros, you stop here, right?
Right.
If it wants the intercepts, you go here.
Right.
How about our vertical intercept?
Now
What
they
is-
want the Y's.
Yeah, and we don't know what our y is, but we know our x is 0, right? So it's
Right.
0 minus 6. 0 plus 1. 0 minus 2. So you have negative 6 times 1 times negative 2. Which is what?
Oh, you put them all together. Oh, okay. Okay.
6 times negative
Let's
2.
see. 12.
So your intercept is 0, comma 12. And again, that's just plugging in 0 for x.
Right. So on the x intercepts, they all different answers, but the y you put them all together.
Yeah, so
Okay.
remember this is a graph and it's a function.
Oh,
And in
right.
most cases, it's probably only going to cross the y axis one time, right?
Got you. Got you.
Everyone feel okay about this one?
Yeah.
Can you fill it in, please, just so I know like what needs to be there?
Yeah. So we said our vertical intercept was 0, comma 12.
Right.
And we said our horizontal intercepts going to be using commas for them. So we have 6, 0, comma,
1.
negative 1. Don't forget the negative.
Uh,
I almost did. Comma, and then 2, 0, comma. Pretty solid? There we go. Now I got it back. Does anyone have any other questions on this? And if not, does anyone have any other questions at all?
no, I think that's it.
Okay, well, thank you guys for coming to the review. Just remember, you can come to the Learning Commons during our office hours for online or in-person tutoring. It's drop-in, so you don't have to make an appointment. So if you're working on a test review or finishing up some homework to prepare for the test, please feel free to come see us and get some assistance. And good luck on test 2, guys.
Thank you.
Yeah, thanks for coming.
Yeah.
Thank you. Have a good day.
Have a good one. And yes, for those with Miss Mays, I will verify your attendance
Thank
with
you.
her. Okay. So let's save that chat.